Now, section 5. Why VAN? That's basically it, because you're already doing it, and the ability to localize. Okay, if you test all those cortical symptoms, you can actually localize. Again, there's no need to calculate score. There's no need to test severity. You're testing all the cortical symptoms. Does not test one MCA branch multiple times. Okay, has these online forms, has the website, has the tool to localize, right? And the mobile app. So I think there's a lot of reasons for it. And just like I showed you, you can actually do any scale via the VAN methodology. Not any scale, most scales you can do via the VAN methodology. Again, I'm just going to go through this. This was the one study I mentioned earlier out of Switzerland. What are the best predictors on the NIH stroke scale? As you can see, it's gaze, motor, aphasia, neglect, and visual fields, which is basically the things we test in VAN. So that's 1,000 patients, external validation of about 1,000 patients, okay? And here, we tried to find, this is their exact words, we tried to find the best combination of NIH stroke scale sub-items to predict LVO in our cohort. Gaze, visual fields, aphasia, neglect, and motor weakness were the items with the strongest correlation. I didn't say it, but thank you for validating VAN externally. And then here's another one. So this study actually looked at, let's look at leukoariosis. That means old strokes or white matter changes. And let's see which tools work the best if you have white matter or old strokes. And they found FAST-ED and RACE do, right? But what's very important is you saw half of the LVOs were NIH stroke scale less than 10. And if you look at it, the positive predictive value for FAST-ED was 35%, RACE was 40%, VAN was about 30%, same as Cincinnati pre-hospital stroke severity scale and 3-item stroke severity. But what's very important is you look at the sensitivity. RACE missed 50%, and FAST-ED missed about 63%. And guess which one performed the best and was the most sensitive? VAN picked 70%. So again, it's just showing you can't be both sensitive and specific. But this is important because this is another validation that VAN does work. And you can see the area under the curve are very similar, but one is more sensitive and one is more specific. And really, accuracy is a relationship between what? It's a relationship between prevalence and sensitivity and specificity. So if your prevalence is very high, you want the more sensitive tool, right? Because it's more prevalent in the community. If your prevalence is very low, you want the more specific tool, right? For instance, if you have 100 people with LVOs, 100 people with strokes, and only 2 have LVOs, right? Only 2 people have LVOs. If you miss 50%, you're only missing 1 person. Now let's take that same group, but your LVO prevalence is 40 to 50%. If you miss 50%, you're missing 25 out of 50. You're missing 25% of the population you could have helped. That's a problem. You cannot use a severity scale there if the prevalence is that high. If the prevalence is really 40 to 50% or even 30, you can't be missing 50%. That's a lot. And so it's all about what is my community? What is the epidemiology of my community? Do I want a more sensitive or a more specific tool? And as I showed here on this graph, the less prevalence you have, the more specific you want. The more prevalence you have, the more sensitive you want a tool. And so we said, so there was one study shows VAN works, and another one from Switzerland. So we're up to 1,250 patients, right? Now there's a study out of Penn State, which was in the International Stroke Conference in 2018. And they looked at 973 patients. And they're like, which tool performs the best? They retrospectively did from the NIH stroke scale. Now I'm reading this verbatim from them. VAN performed the best and correctly identified the presence of LVO as detected MRA or CTA 89% of the time, leaving a false negative rate of only 11%. On the contrary, RACE performed the worst and was only able to correctly identify LVO 72% of the time, resulting in a false negative rate of 28%. Conclusions, okay? Pre-hospital detection of LVO remains a hot topic of ongoing research, and while the optimal scale remains of yet undetermined VAN appears to show great promise, but validation of its specificity has not yet been adequately assessed. All right, so this is another 1,000 patients. And so that's external validation in multiple areas. There's actually even more. But this just shows you with over 2,000, 3,000 patients that VAN does work, and that what we say about it being 70 to 90% sensitive is true. Okay. So basically, VAN is very similar to NIHO scale of 6. Those other severity scales are closer to NIHO scale of 10. Okay. So then they're like, but some people say, but who cares about low NIHO scale LVOs? Well, there's been multiple studies, retrospective, we're still doing the prospective ones, but those large vessel occlusions, or there's a big clot, but your symptoms are minor, the question is, do you get worse or better? And we've seen anywhere from 25 to 50% go into collateral failure. That means they'll come in looking okay, within 2 to 3 hours or within 24 hours, they actually get much worse. So being able to identify those patients is very important. Where do I put these patients? Comes in at about 5-6 hours, NIHO scale of 6 or 7, but they, now they're VAN positive, so you do CT, CTA, you find a clot. This helps you manage them. If you're triaging based off of a severity scale, oh, well, their NIHO scale is not 10, they don't have severe weakness, let's not worry about it. And they're going to a primary center where they're only getting a CT and you have no idea they're going to go into collateral failure. That's a problem. And so the point of the matter is, we do need to identify these, because from what we know so far, it could change. 25 to 50% of these people do get worse. And so you do need to identify these patients. Another problem is most primary stroke centers do not have neuroradiology on 24/7. I showed you those 2 examples. I got 100 other, where the clot is missed, right? And so having a tool, now an ED physician can use my app, a nurse practitioner, a nurse at the bedside, a savvy tech can actually examine the patient, anyone can, and can use all the symptoms and localize where the clot is. And it can help our radiologist identify them. Again, those 2 or 3 examples I gave, that's the tip of the iceberg. And remember, most primary stroke centers do not have neurorads 24/7. You need to help your radiologist, all of us, everyone needs to. And I think VAN, with the website, with the localization, with the app, can do that. So I'm going to go over this one other study, because this NIHO scale thing is very important, and using severity only versus type of stroke scale, right? Because that's what we're really talking about. Type of stroke versus, that's just a severe stroke, is basically this study, which was very powerful. I think it was over 2,000 patients, and they looked at LVOs when they present between 0 to 3 hours, 3 to 6, and 6 to 24 hours. What NIHO scale do they present with? And this is for anterior circulation, this slide number 1. You can see for anterior circulation, okay, the average NIHO scale is about 9 to 10 from 0 to 3 hours. But you look at 3 to 6 hours, the average NIHO scale goes down to 7. And then if you go to 6 to 24 hours, the average NIHO scale for a large vessel occlusion is actually 5. What does that mean? That means your collaterals are so good, that you come in later with minor symptoms, but that means you can actually get worse. So this is important to know too, right? And then for posterior circulation, basilar PCAs, that average NIHO scale is like 5, no matter when you come in. These are very low scales for large vessel occlusions in the posterior circulation, a P1 PCA or basilar. And this is a combination of both of them. And this is a systemic review from the American Stroke Association, which basically from 2018, which says basically accuracy of prediction instruments of identifying large vessel occlusion. They basically said there's no tool that's sensitive and specific. If you want to be sensitive, you're going to be less specific, and vice versa, which I think is very reasonable. But so this is important to know as well. And here's another thing that I think is very important. When you're reading any paper, it's important to know, how was that done, okay? How was this research done? Because if you look in the field, people are going to have hemorrhages, subarachnoid hemorrhages, seizures, tumors, toxic metabolic encephalopathy, and strokes. Versus if you look at a paper which used a stroke database, they don't have any of that. As you can see this, all they're looking at is ischemic strokes. So all their numbers are actually not true for the field, right? Because they've already taken out the tumors, the seizures, the hemorrhagic strokes, the subarachnoid hemorrhages, right? They're only looking at ischemic strokes. So this is very important, is what subset are they using? And lastly, I just want to present this as well. We finished our multi-city VAN validation in the field, and basically what it showed, we have about 250 patients from 3 different cities, Phoenix Metro, San Antonio, and some parts of Toledo, Ohio. And our positive predictive value is almost the same as NIH scale of 6. So we performed almost the same as the NIH scale of 6. And this is validated in the field. Again, a positive predictive value about 35%, which is similar to what others have reported. But again, if I included the hemorrhages, the tumors with mass effect, the subarachnoid hemorrhages, that positive predictive value goes up to 50. And those people need to go to comprehensive stroke centers anyway. And again, this is just late-breaking news, just so people know that this has been validated in the field, in addition to the 3,000, 4,000, 5,000 patients that has been validated in external sets, which I have nothing to do with, publications that are not part of what we're doing here.